Students, the question is, among the electrolytes Na2SO4, CaCl2, Al2SO4 whole thrice and NH4Cl, the most effective coagulating agent for Sb2S3 sol is option A is Na2SO4, option B CaCl2, option C Al2SO4 whole thrice and option D NH4Cl. So here we need to know one thing, that the correct option for this answer for this question is third option which says Al2SO4 whole thrice. Now why we have chosen this answer? See, we all know that Sb2S3, that is basically your negative sol, right? Now it is your negative sol. So Al2SO4 whole thrice will be most effective coagulated. Why? Because of the higher charge density. Always remember, because of, you can say, higher charge density on Al3 positive, right? That will be higher charge density on Al3 positive. That is according to Hardy-Schuzzel rule. Okay? So according to, you can say, Hardy-Schuzzel rule, what happens, that you need to know, that according to this rule, what will happen, the greater will be the valency of active ion. Always remember that greater will be the valency of active ion, greater will be its coagulating power, right? So here what is there, that greater will be the valency, greater will be the valency of, you can say, coagulating agent, yeah, you can say active ion, then greater will be the coagulating power, right? Now here what will be happening, greater will be coagulating power, right? Now what will be happening, that according to, you can say that according to Hardy-Schuzzel rule, the ions which will be carrying the charge opposite to that of sol particles, they will be effective in causing coagulation of the sol. And secondly, the coagulating power of an electrolyte, that will be directly proportional to the valency of active ion. So yeah, what will be happening, that order of effectiveness, if we talk about order of effectiveness of cations, it will be in the form Al3 positive will be maximum, then it will be the case of Ca2 positive according to the valency, right? Then it will be Na positive, and then it will be NH4 positive. So according to this rule and according to the coagulating power, Al3, that is aluminium sol, that is Al2SO4 whole thrice, will be the best coagulating agent. So option C will be correct.
Hello everyone, this is our question. Let me explain it to you. Among the following, which surfactant will form micelles in aqueous solution at the lowest molar concentration at ambient conditions? So if we talk about the micelle formation, so let's say we are talking about the associate colloids, right? So what happens now in this case, if we talk about the low concentration, at low concentration, then particle size here is less than the size of colloidal particles. Particle size is less than the size of colloidal particles. Now what happens if we are having the concentration, if the concentration increases, this was at low concentration, but at high concentration, concentration which is higher than the critical micelle concentration, the minimum concentration at which micelle formation starts taking place, then these molecules are going to come closer to each other and they would start aggregating, and this leads to increase in the size of the particles. Okay, so when the aggregation happens, then the size of these particles increases or almost becomes equal to the size of the colloidal particles. Okay, so if we talk about these particles, like we are talking about simply RCOO Na, this is the polar part, and R is the alkyl group basically. So we are talking about this particle size. Okay, so directly this is depending on the surface area of the particle, this alkyl group that we are talking about. So this thing is depending on the area of particle. If the surface area of the particle is high, then what happens? The size of the particle will just be equal to the size of colloidal particles very fast. When the size is same, or we can say almost same or more than the size of colloidal particle, then there would be the micelle formation rapidly that is going to take place. Okay, so now in the given options, we will see the surface area of the particle on the basis of number of carbon atoms. So if more carbon atoms are there, we will say that it has more surface area. So for the first case, if we talk about here, we have 15 carbon plus 1, 16 and plus 3, right? 15 and these 3 carbon plus 3, 15 plus 3, 8, 16. So here we have total 19 carbons. Okay. In the second, if we talk about 11 plus 1, 12, 12 carbon we are having. Okay. And in the C1, we have 6 plus 1, 7 plus 1, 8 carbon atoms. And in the last one, we are having 11 plus 112 plus 315 carbon. So we can say that number of carbon are maximum in A, so it would be having the surface area highest. So if the surface area is more, then the particle size will become equal or more than the particle size of colloid, and there would be the micelle formation occurring very fast. So option number A is correct. So in this option, this surfactant will form micelles in aqueous solution at the lowest molar concentration at the ambient conditions. Okay, thank you. Hello everyone, this is our question. Let me explain it to you. Lyophilic sols are, these are some options and we have to identify the true statement. So let's understand first of all about the lyophilic sols. Okay, so lyophilic sols are basically having phase and medium in them, in which there is a very high attraction. So between the phase and medium, we are having very, very strong attraction, strong fusion of attractions, keeping them together, right? And because of this, if we talk about the coagulation, then for coagulation, there is a large amount of electrolytes that is required. For coagulation, large amount of electrolytes is basically required. Okay, so if we talk about this, then if we are having if we add large amount of electrolytes, then finally the phase and medium which we get after separating them, they are obtained in the same phase. Right. So we can clearly see over here, if we see the first option that they are irreversible source, then they are not irreversible source, because initially phase plus medium were there, and finally after adding large amount of electrolytes, you will get the same phase of the phase and medium. Okay. So such kind of the sols are basically reversible sols. So first statement is wrong because they are reversible. The second is saying they are prepared from inorganic compounds. So this is also wrong. So if we talk about the second statement, we are having organic compounds, right? And those organic compounds basically are formed when the bond making power is strong, or rather we can say the bond strength is strong, and also they are liquid loving in nature, right? Liquid loving. So this is how, with the help of organic compounds, we make the lyophilic salts, because they are also liquid loving here. So they are prepared from inorganic compounds. Is the wrong statement. The third is saying they are coagulated. They are coagulated by adding the electrolytes. So just because we talked about there is a very strong attraction between the phase and the medium, so it just the small amount of electrolytes, or the normal concentration of electrolytes is not enough to coagulate them. Okay, so we can clearly see it's written large amount we would be requiring. So for the normal process to do the coagulation is not possible because of high attractions. So option C is also wrong. Now the option D is they are self-stabilizing in nature. Now this is absolutely true. So we can see over here that because they are having very high attractions, so this leads to the point that they have this self-stability which keeps them binding together, and the coagulation is not very easy. So option number D is the correct statement, that they are self-stabilizing in nature. Okay, so D is the answer. Thank you.